Strictly speaking, precipitation is any liquid or frozen water that forms in the atmosphere and falls down to the earth, and it comes in many forms such as rain, sleet, snow, but it also includes mist and fog. When the raindrops coalesce and become heavy enough, they fall to earth, and when the clouds are high enough, the rain freezes to form snow or hail. In some areas of the planet where there is limited rainfall, the main source of precipitation is fog. Rainfall can be measured using a standard meteorological office rain gauge. These consist of a brass cylinder that incorporates a funnel leading into a collection bottle. The instrument is set into the ground to keep it from falling over and to keep the collected rain cool to minimize evaporation. The water collected is measured as a depth of rain, usually in millimeters, by pouring it into a measuring cylinder that is calibrated to give the correct answer. The bottom part narrows so that you can measure very small amounts of rain, down to 0.1 millimeters. There are ways of improvising rain gauges, and two examples are shown here. One uses a drinks bottle that is placed inside an inverted plant pot. The second method is to slice up a large plastic drinks bottle and use the top part as the funnel. In both cases, the volume of rain collected must be converted into a depth, using the formula given in Field Hydrogeology on page 103. Daily rainfall measurements are taken at 9 a.m. Greenwich Mean Time all the year round. That measurement covers the rain that fell from 9 a.m. on the previous day and is recorded to the nearest 0.1 millimeters. When the rain that fell is less than 0.1 millimeters, it is recorded as a trace. The rain gauge should be set up in a location where the rainfall is not disrupted by trees or buildings. It should be away from the trees or buildings by at least twice the height of them, and the angle from the top of the trees or buildings should be less than 30 degrees. To calculate the rain that fell on a catchment, use the Tyson polygon method. First, connect the rain gauges by a series of straight lines. Draw a perpendicular line at the midpoint and extend these lines to create polygons. Assume that the average rainfall over each polygon area is measured by the rain gauge at its center. Multiply the area of the polygon that falls inside the catchment by the depth of rainfall recorded at the rain gauge. An example is shown for rain gauge G, where the rain falling on the shaded area is taken to be the depth of rain measured at rain gauge G multiplied by the shaded area. Note that rain gauge G actually lies outside the catchment.